Hello and welcome to I Know Dino. Keep up with the latest dinosaur discoveries and science with us. I'm Garrett.
And I'm Sabrina. And today in our 488th episode, it's the April Fool's Day episode.
But we're still talking about dinosaurs.
Well, if you have been listening the last few years, then you know it's more bird-like than usual. We've got feathers and birds and bird-like non-avian dinosaurs and even some fictional characters that are going to make an appearance.
And for the dinosaur of the day, you're doing Microraptor Revisited, which is very exciting.
Yes, plus a few more, I'm going to say cameos because they're characters. Thank you to our patron Robert, who said, quote, "If you stick with the bird theme, it's clearly your April Fowl episode, perhaps as bad as the thesaurus jokes I know." I would argue perhaps as good as the thesaurus jokes.
April Fowls. That's silly.
I think we're actually releasing this episode close to April Fool's. It's hard to get it exactly.
It was exactly one of these years. I think that might be when we started doing it as the April Fool's episode because we realized, wait a second, dinosaurs are birds. No one will expect this. But before we get into this special episode, of course, we want to thank some of our patrons. And this week we have 10 patrons to thank, as usual. And they are Danny Hermes, Anne, Elrex, Riker Tattoo, Jesse, Trent Carbajal, Thieving Raptor Lorenzo, Adilosaurus, Richard, and Kumakani.
Yes, thank you so much for being in our Dino It All community. It's because of our patrons that we're able to do our April Fowl episodes because a lot of these suggestions came from that community.
And I guess we're doing April Fowls now. That's going to be the name, sounds like.
We'll see. Stay tuned next year.
Yeah.
All right, jumping in. Like I promised with feathers, dinosaur feathers were a lot more like bird feathers than we had thought. There was a study published by Tiffany Slater and others in Nature, Ecology, and Evolution.
And that is a real study. All of the studies in this episode will be real studies, not fake studies like other April Fool's people do.
Right. And our dinosaur of the day, Microraptor, is real, but the other ones that we'll be mentioning that are making cameos are maybe a little less real.
Well, they're like characters.
Yeah. Anyway, it turns out that some dinosaurs like Anchiornis probably had feathers just like modern birds, though previous studies found that that was the opposite case.
So basically meaning that their feathers were more bird-like than those more proto-feathery type feathers than they had.
Yes, and Anchiornis is a very bird-like dinosaur.
Yep. It's usually depicted as sort of having a red tuft of hair on its head. Hair, I should say feathers or proto-feathers.
Mm-hmm.
And then like white and black markings on its wings. It was in that recent Netflix series, Jumping Off a Cliff to Evade Predators.
Yes. So how did it happen that it had seemed that Anchiornis had different structures in its feathers compared to modern birds, but it turns out that that's not the case. They're actually much more similar. It's all about the fossilization process. So the author said in the paper, quote, "Ancient biomolecules are a powerful source of information on the history of life on Earth," end quote. Things like collagen, that's the protein in skin and other connective tissues, can survive for several million years. But what about longer than that? Well, enter X-rays, infrared lights, and a lot of heat.
They're cooking them?
They heated up some freshly shed black feathers from a domestic chicken and some white feathers from a little egret. Black feathers have melanin, so they're good for comparing with fossils. And then the white feathers were the melanin-free control. And they simulated the hot temperatures that fossils would have endured over time. They put them through a 200 degrees Celsius and 250 degrees Celsius, or 392 degrees Fahrenheit and 482 degrees Fahrenheit. And at 200 degrees, both these chicken and little egret feathers looked similar to untreated feathers. But at 250 degrees, they saw more differences. I'm not sure exactly how long they heated the feathers for, though, because the authors in the paper said that there's debate on what temperature to use because previous studies had 100 degrees Celsius. That was found to be too low. It didn't result in any major chemical differences. And up to 250 degrees Celsius for 24 hours, quote, resulted in liquefaction and partial vaporization of feathers, end quote. So that's not great for comparing to fossils. And it sounds like they did not heat their feathers for more than 24 hours then, even though they used the 250 degrees Celsius.
That's interesting. Yeah. I mean, we never know exactly what temperatures rock has been when it's been in the ground for tens of millions of years. So, really, you can try to guess by seeing what the state of the preservation is. But, like you were saying, there's a time component too. So, it's complicated.
It is. And then it was interesting what these heated or treated feathers looked like. But before I get into that, what were they looking for? Well, they were looking for certain proteins in the feathers. Modern birds have a lot of beta proteins, Cronius beta proteins, also known as CBPs, which are fibrous, and they make the feathers more stiff and stronger for flight. In previous studies, like ones with Anchiornis, the study found that Anchiornis had a lot of alpha keratin proteins, which would mean less stiff feathers and not as good for flight. But it turns out Anchiornis may not have had all those alpha keratin proteins when it was alive. Those proteins might have come in as a result of the fossilization process. So the team's experiments with the modern feathers, which simulated the temperatures that fossils go through over time to become what they call thermally matured feathers, they found protein degradation and found that alpha proteins formed.
Oh.
Which, yeah, it could mean that those same alpha proteins formed on Anchiornis after it died.
Wow. Yeah, that is tricky.
Mm-hmm.
If the type of protein can switch like that, I'm not used to seeing that in any sort of chemical process. Usually, if you're talking about a biological chemical, you get either a chemical or you get a different chemical. Sometimes you'll get some more simple chemicals that sort of are the result of one breaking down, but it's not usually the case that one of them breaks down into a totally different. So when you're looking for a beta, you find an alpha. That seems strange.
I don't know the exact process of how the alpha proteins formed, but it is a new way of looking at things and a new lens to look through it.
Yeah, because we've talked before about sometimes you'll get modern contamination too. And so you have to worry about, well, did this fossil actually have that chemical or that protein in it? Or did it get, is it like shed skin off the researcher or something like that? Whereas in this case, it's actually the fossil itself and it's correctly being analyzed as a alpha protein, but it's an alpha protein now, whereas it would have been a beta back in the day.
Yes. Well, so the reason that they think Anchiornis had beta proteins back in the day instead of the alpha proteins is because, well, first they examined some specimens. They examined Confuciusornis and Psiornithosaurus, as well as a fossil feather known as the Green River feather. It's from the US. It's an isolated feather from the Green River Formation from the Middle Eocene, which is about 50 million years ago. And then Confuciusornis and Psiornithosaurus are from the Jiufotang biota, which is Early Cretaceous and what's now China. And when they examined Psiornithosaurus using X-rays and infrared light, they found that Psiornithosaurus, which is basal to Anchiornis, had mostly beta proteins.
Oh, so they didn't all get mixed up in the fossilization record. Some of them stayed beta proteins.
Yes. I don't know the exact details of what made this so different.
Well, it's probably just that it was preserved differently, that it didn't get switched over to alpha proteins in the decay process.
So they said they didn't think this was an independent origin of modern flight chemistry. Like, it's not just something that is in Psiornithosaurus and not the whole group. And that would suggest that Anchiornis had a similar chemistry in its feathers with the beta proteins. And the study found otherwise based on heat changing the fossils during the fossilization process. Diagenetic alteration is what it's called. So they think Anchiornis had feathers similar to modern birds, again with the beta proteins. So overall, they found that dinosaur feathers had similar proteins to modern bird feathers. And that would mean that dinosaurs had stiff feathers. And again, stiff feathers are stronger for flight. And that could mean that bird feather chemistry originated much earlier, maybe as early as 125 million years ago. So you just have to keep in mind the influence of the fossilization process when studying these things like fossil proteins. And you also have to take into account the sediments that the fossils are buried in, because that can make a big difference.
Yeah. Also the temperature, but you can't really tell that for after the fact. Or maybe we'll figure out a way to at some point.
Yeah, never say never.
I was just looking at the structure of alpha versus beta keratin. And it's interesting because alpha keratin is basically helixes. So they're sort of like single long threads, you could almost think of them as.
Mhm.
Whereas beta keratin are actually put into sheets. And you could almost imagine them being like a bunch of alpha keratin stuck together. They're a little bit flatter than they are. They're not in a helix shape because of the way that they're bound together. The individual strings, in my analogy, of the beta keratin together. But you could imagine how if the bonds get cleaved between those strings in the beta keratin sheets, that they would be available to sort of go into that helical shape of alpha keratin.
Mm-hmm.
So in this case, it does make sense that over time that might make that change from a chemistry standpoint. It was very clever of those researchers to notice that.
Yeah, when it comes to dinosaurs, it's nice to be able to bring together a whole bunch of different disciplines.
Mm-hmm.
Well, feathers are kind of the first step for flight, and scientists also have a new framework for figuring out if a dinosaur could fly. And this was a study published in PNAS by Joseph Kjat and Jingmei O'Connor. It turns out that all flying birds have the same feather features in common. They examined 346 species of birds, and all flying birds have between 9 and 11 primary feathers. Flightless birds have a different number. Emus, for example, have none, and penguins have more than 40.
Why aren't penguins flying if they have so many flight feathers?
It's too many. Too many
So.
primary feathers. Oh, also, the primary feathers on the tips of bird wings are always asymmetrical in birds that fly and symmetrical in birds that don't fly. So that's two traits that you want to look for. The number of primary feathers being between 9 to 11 and the feathers being asymmetrical if you're trying to determine if a non-avian dinosaur was flying.
Yeah, maybe. I guess. We have talked about how maybe some birds with symmetrical feathers were still capable of flight.
Yes. But it's a framework to work with.
Mm-hmm.
They examined 65 fossil specimens, 35 species of feathered non-avian dinosaurs and extinct birds, and they compared the modern birds to the extinct animals, and they found the overlap, meaning which extinct animals were able to fly based on this framework. And this finding helped show how dinosaurs first evolved to fly. They looked specifically at Peniraptorans. That's the clade. They're known for having feathers. They include animals like Oviraptor, Deinonychus, and the house sparrow. It's a subgroup of Maniraptora, which is a clade of Coelurosaurians, and that includes birds and non-avian dinosaurs like Dromaeosaurs, Troodontids, Oviraptorosaurs, Therizinosaurs, Alvarezsaurs. Lots of saurs. And ids. Anyway, Peniraptorans developed feathers before they could fly. Those feathers, maybe they used them for insulation or attracting mates or something else, which that will bring me to our next paper.
The something else?
Yeah.
Ah.
But first, one Peniraptoran is Caudipteryx. That's a small oviraptorosaur that lived in the early Cretaceous in what's now China. And it was our dinosaur of the day back in episode 458, if you want a refresher.
Pretty recent.
Yeah. It had long legs, but it was small. It was about 2.5 feet or about 0.7 meters long and weighed about 11 pounds or 5 kilograms. And it was covered in feathers. We think black feathers on its body and then a banding pattern on the tail feathers, which fanned out. Caudipteryx had 9 primary feathers, which is the right number, but they were almost symmetrical, and the proportions of its wings mean that it couldn't fly.
The proportions of wings, to me, are a better way to determine if a bird could fly or not than the symmetry level of the feathers or number of feathers.
I think the more features that you have to look for, the more accurate you'll get.
Yeah. It could also help figuring out which ones were the ancestors to modern birds. Because if all the modern birds have this thing in common where there's no real reason that 9 to 11 is the magic number.
Mm-hmm.
But if if you have 2 competing lineages and one of them, they all have 9 to 11 and the other ones they have like 17, then it could help you narrow it down. Yeah.
Well, in the case of Caudipteryx, the thinking is like maybe its ancestor could fly, but then the ability to fly was lost.
Mm-hmm.
So it's secondarily flightless. There are other fossils where they seem able to fly based on this criteria. That includes Archaeopteryx and Microraptor, which, based on other studies, we've talked about both of them flying
And
gliding.
And how well, they could fly.
So this study could help show the origins of dinosaur flight, and the findings suggest that flight evolved once in dinosaurs, but there's still a lot to learn. There was one person on the dinosaur mailing list that said they were skeptical of the author's hypothesis that Pentaraptorans are primitively volant, able to fly or glide. Because if that were the case, all Pentaraptorans that don't fly or glide would be secondarily flightless, because their ancestor could fly or glide, which is non-parsimonious. It would seem to be more complicated than it necessarily is, as it would, as they pointed out, mean there would be multiple losses of flight in Dromaeosaurids alone.
Oh, I see, because Dromaeosaurs or raptors are Pentaraptorans, and
Yes.
none of them could fly.
Yeah, think like Velociraptor. We know it didn't fly.
And that means that if Velociraptor had an ancestor that could fly, it would have lost flight, as would have maybe other Dromaeosaurs.
Mm-hmm.
Yeah, I don't know. I mean, some people think that Archaeopteryx was secondarily flightless. So that's going way back to the Jurassic and something that looks a lot more like a bird than a Dromaeosaur does. So, depending on how back that common ancestor goes and what that common ancestor was up to, it's definitely possible either way.
Yeah. But again, I think it's nice to have these frameworks and adding more information to figuring out the answers to these questions, and also just knowing, there's still a lot to learn, but we can keep adding to it.
It's definitely very useful for figuring out the origins of birds.
Mm-hmm.
Which ones are the crown birds, in quotes, meaning the ancestors to today's birds?
Yes. And we will talk more about dinosaurs and what they use their wings for in a moment. But first, we're going to take a quick break for our sponsors. All right, as I alluded earlier, there might have been other reasons for dinosaurs to use their feathers, in addition to keeping warm or attracting mates, and eventually flying. And this was a cool study. This was published in Scientific Reports by Jin-Seok Park and others. And this team built a robot dinosaur to test how they use their quote-unquote half wings.
Were they swimming?
No.
Were they jumping really high?
No.
Were they falling slower than usual? I'm doing trees down, ground up, and I threw in an aquatic one for some reason.
The robot had its limitations, I'll say.
I see. They weren't throwing it out of trees.
Yes, it wasn't moving that much.
Okay.
But those were all good guesses. So we're back to Pentaraptor and dinosaurs, because they've been found with pennaceous feathers. Those are feathers with a stalk or quill on their arms and tail, and those are the types of feathers used for flight. But when they first developed, the dinosaurs had wings that were small, known as proto-wings, which are like half a wing, and they weren't strong enough for flying. So why then did they have them? Well, we talked about some ideas before: keeping warm, attracting mates. There's the idea of brooding. There's wing-assisted incline running, running while flapping, pouncing on prey, immobilizing large prey, leaping for prey. Lots of stuff to do with prey, which is a hint.
So they were seeing how helpful it was for hunting?
For specifically the flush pursue hypothesis.
Flush pursue?
Yeah, I don't think we've talked about that one before.
Is that like something's in a burrow and you flush it out and then you chase it down?
Exactly.
Huh.
Some birds do this. They'll use their wings and or tail to scare the prey out of hiding and get them into fleeing mode and then chase after them.
That's pretty dumb prey. Why is it running out of hiding when it is big and flopping around?
Well, there was a study on the nervous system of insects that found that insects have special neurons that get activated by these flush displays, so they can't help it. But there's a lot of studies done of birds that eat insects. And some examples of birds that eat insects are the northern mockingbird, which flashes its wings and then goes after worms. There's a fun little video clip I found of it.
Oh, so it's not flapping at them, it's just showing its wings.
Yeah, it's a display thing.
Oh, okay.
That scares them. And many of the birds that do this often have black and white patches on their wings and tails, and that triggers the prey to try to escape. And then the birds use their wings and tails to help them catch the prey. Insects aren't the only ones that will try to escape and flee. In these situations, there's a lot of prey animals that try to escape in response to visual stimuli. Flies, crabs, crayfish, small mammals, and then orthopterans.
What's an orthopteran?
The order Orthoptera has been around for 300 million years, and they include modern animals today like grasshoppers.
Oh, okay. So another type of insect, I guess.
Mm-hmm. And these are all things that Pentaraptoran dinosaurs likely hunted. You also see the flush pursue strategy with moles and earthworms, cheetahs and antelopes, and squid and shrimp.
That is so many animals that get tricked by this one simple trick to catch prey. I feel like it's going to be like a BuzzFeed article for birds. Just hold your wings out and they'll run away and you can catch them so easily.
You might have to flap.
You do? Oh, sometimes you do have to flap a little?
I think you do have to flap.
Okay. It's weird to me that all these animals, after millions of years coexisting with birds, are still so easily tricked. It makes me wonder if it's not that common of an occurrence. You know, like it just happens once in a while, and that's why it's so startling and confusing to these animals, and then they get eaten. Just seems like selective pressures would make it not so effective over time.
There are a lot of videos of birds doing this.
Huh. Interesting. Seems like at least mammals should be able to work that out.
So it could be that small dinosaurs with proto-wings did something similar, like you were saying. And small omnivorous and insectivorous dinosaurs specifically might have flapped their small proto-wings to scare prey out of hiding places. So a good dinosaur to test is Caudipteryx, which was a two-legged, peacock-sized dinosaur that lived about 124 million years ago. It had short arms and a tail and a reduced third finger. And it also had small proto-wings and pennaceous feathers around the tip of the tail. The team picked Caudipteryx because it was a Pentaraptoran, and pennaceous feathers were found in that group. And it's also a basal taxa, so it represents the ancestral condition of Pentaraptora. As they put it, the, quote, most representative basal-most Pentaraptoran, end quote. Its feathers are symmetrical and highly simplified compared to flying birds, both extinct and modern ones. And we know the colors of the tail and body feathers, and that it had these visible banding patterns. It had a striped tail. Additionally, there have been gastroliths found with Caudipteryx that may mean that it ate hard-to-digest plants, but it could have also eaten arthropods with hard exoskeletons, because some modern lizards do this. So maybe Caudipteryx was an omnivore. So it had a lot going for it. It's a basal member of its group. It's got the pennaceous feathers. We know what it looks like with the colors and the banding. And maybe, just maybe, it ate insects.
And we think it ate insects because of the gastroliths? Because there are some lizards with gastroliths that eat insects?
Yes, yeah, some modern lizards do that. So it's possible Caudipteryx also did that. Although I would think that's more speculative. So the team constructed a robot called Roboteryx, which resembles Caudipteryx. And this robot had 9 motors, and it was programmed to imitate the movements of ground-foraging, flush-pursuing birds, like the roadrunner or the rufous-tailed scrub robin. It also had wheels to make it stealthier, and they used black paper and black felt to cover the robot. And they did tests to see how wild grasshoppers responded. Again, because grasshoppers are part of that order Orthoptera, which has been around for 300 million years, so some of them coexisted with dinosaurs. They had the robot do different movements, including spreading the proto-wings and raising the tail, and then pausing, and then folding them back. And they focused on the shoulder angle, the elbow angle, wrist angle, tail angle for the robot. They looked at Acrocanthosaurus, which is a more basal dinosaur, and Bambiraptor, which is more derived, to figure out the range of motion at the shoulder joint, because Caudipteryx is in between the two.
And presumably they don't have a good enough shoulder to figure it out on Caudipteryx specifically.
And then, like I said before, the robot had some design constraints, so they kept a simple up and down movement for the tail because they couldn't do sideways movements.
Okay. This is a much more simple robot than I was imagining, because I was imagining that they were actually testing what the wings could do, but really they were testing how grasshoppers respond to a, like, almost like an RC car with a Caudipteryx strapped on top of it.
Something like that, yeah. To that display and scaring them out of hiding kind of thing. Who knows, though? Maybe they'll build more complex robots in the future.
That'd be good.
This one's still cool. There were some other constraints too, like it couldn't fully imitate natural body movements evolved in foraging activities. So they focused on imitating specific moments in the flush display, as seen in some flush pursuing birds. So when the bird's stationary and it's using the arms and tail to scare the prey.
Oh, that's cool. So it could do more than just drive around with its wings outstretched. It could move a fair amount, just limited to a very specific situation that they were trying to model.
Yeah, exactly. Yeah, a limited test first.
I guess when I heard that it had half wings, I assumed that it was using the wings as wings, and they were testing one of the hypotheses about the evolution of flight, which they kind of are, but they're doing it from a different angle of evolution of flight as a sort of byproduct of this other specific interesting behavior we've never really talked about before.
Yeah. So they tested only adult male grasshoppers because they said, quote, the escape behavior of orthopterans is likely affected by sex, end quote, which I didn't realize.
Makes sense. You want to eliminate as many variables as possible.
Mm-hmm. They found that grasshoppers escaped or fled more often when the robot used its proto-wings on its arms. So 93% of the grasshoppers tested fled when they used the proto-wings, versus only 47% fled when no proto-wings were used.
That's a pretty big difference.
Mm-hmm. They also found that grasshoppers fled more when the proto-wings had white patches on them compared to being plain black. And grasshoppers also fled or escaped more frequently or when there were tail feathers being used. The team also made some computer animations of hypothetical displays by Caudipteryx and showed those displays to grasshoppers in a lab and then recorded their neuron responses and found that the reactions were higher in response to animations with proto-wings.
Wow. So they hooked up their little grasshopper brains to a computer?
Yes, they were very thorough in their testing of the grasshoppers.
Yeah.
So based on these tests, it seems that Caudipteryx and other dinosaurs could have done the flush and pursuit, which could be why feathers on wings and tails initially evolved in dinosaurs. They'd use their contrasting colored feathers on the wings and tails to startle the prey out of hiding, so the prey would flee, and then the dinosaurs could chase and catch them. And the feathers on the tail and arms would help them generate drag and or lift while they were pursuing the prey, so the running while flapping thing, or help them attack the prey, pouncing on the prey. Having quick movements with a long neck and also maybe the arms or legs would have helped them capture the prey, which the proto-wings would help by acting as insect nets or helping to immobilize the prey.
Stunning them midair with a big wing slap.
Yeah.
All this is reminding me of when I'm trying to catch a fly occasionally buzzing around and I lose track of it. And I try to just like make a bunch of motions near where I think it is to try to scare it out. And it never seems to work. Maybe I need to get a piece of paper that's like white and black banded or something and see if that'll work better to sort of startle it out of wherever it's hiding.
Or construct your own fake wings.
Yeah. Or a full Caudipteryx robot. Walk around the house with.
Yeah, a multi-use robot for research and catching flies. The authors did say that the light and dark tail fan on Caudipteryx, though, might have also been for display and communicating, regardless of whether or not it helped with this flush pursuit hypothesis.
Yeah, but it could be both.
It could be. And they said that this flush pursuit hypothesis can account for the presence of feathers, their location, and the color contrast on Pentaraptor and dinosaurs. It's also consistent with proto-wings in relatively small theropods who hunted insects. These proto-wings would have helped with rapid changes in speed in direction when chasing after prey. Or I should say the feathers would have helped with that.
Yeah, I think we've seen that with hypotheses with like Dinosaurs, like raptors, where they thought maybe they stuck a wing out basically at a full sprint and that wing would catch a bunch of air and it's almost like grabbing onto something like a tree branch or something to spin yourself around. So I guess that could help if you're trying to chase something really small and agile.
Yeah. And then all of these adaptations could have laid the foundation for evolving wings and eventually powered flight. Though not all scientists agree with this. There was an article in Smithsonian Magazine where Michael Benton said that he wasn't sure and that the first feathered dinos may have used their wings to glide, and even with half a wing, it could have done well. He said, quote, half a wing is what many modern gliding lizards and mammals have, end quote.
Yeah, And it doesn't necessarily even have to be for gliding or flying or anything like that, because the wing-assisted incline running is basically flapping upside down. They're like trying to create more downforce so their feet get more traction running up a steeper hill. And then any amount of additional downforce you can create helps you run up a steeper hill. So, or a steeper branch in the case of most examples.
Yes. Plus, it's really hard to prove that these dinosaurs use their wings to go after prey like insects.
Yeah. I think the way to prove it might be if you could find a fossilized feather that had sort of like some insect like legs or something stuck into it in a way that you wouldn't expect unless they were intentionally sort of batting at insects, which is the kind of thing you could find.
Yes, it's possible. And like you said, Garrett, too, the proto-wings could have had more than one function.
Yeah, at the very least, they were probably used for display in addition to something functional.
Yeah. So lots of interesting theories and frameworks going on with feathers that affect how we think about dinosaurs. We'll move on to our dinosaurs of the day in just a moment. But first, we're going to take a quick break for our sponsors. And now on to our dinosaurs of the day, because we have a few to cover in this episode. Like I mentioned before, there's a few cameos. I don't know if cameos is the right word. You can't see them in this podcast, but you get the idea. They're making an appearance.
Fictional characters.
Yeah, thank you. And I want to thank all of our patrons who put in these requests. Since we started doing our April Fool's annual episode, I do collect these requests from throughout the year, so some of them were from a while ago. But we didn't forget.
Sabrina's good about that. Good documentation.
Oh, thank you. So I'll start with the Toronto Raptors mascot, the Raptor. This was a request from Raptor Yelts via our Patreon Discord, so thanks. The Toronto Raptors are an NBA, National Basketball Association team based in Toronto, in Ontario, Canada. The team was founded in 1995, and it's the only Canadian team in the NBA. Their mascot is the Raptor because the team name Toronto Raptors was influenced by Jurassic Park.
I guess they were founded in 1995, so that makes sense.
And the Raptor's meant to be a velociraptor because it's quick and it has lots of endurance. The fans were asked to choose the name in 1994, and they had a final list of 10 options that included dragons, T-Rex, and raptors. So there were a lot of dinosaur or dinosaur-like options there. The team colors, they're red, purple, black, and silver. The raptor's not the most realistic-looking dinosaur, but it does look aggressive, and it's meant to be an aggressive dinosaur.
I feel like every modern mascot is basically like you take an animal, you turn it into a fluffy, friendly-looking stuffed animal type appearance, and then you make it angry. Then you've got your mascot. Because they got to be fearsome, since you're going to win sports.
Yeah, that could be. I haven't paid too much attention to mascots, I guess.
It's generally how they look.
I only look at the dinosaur ones.
Yeah. Which is, there's only one in the NBA, unless you're including birds. I was also thinking of bird mascots.
Well, we've talked about hockey mascots too.
Yeah, a lot of them look angry too.
Well, this one, the Raptor, it's red. It wears jersey number 95, which is the year the franchise was established. And it does this raptor claw move after every win. The Raptor performs skits and dances and also cheers at games. And I read that there's 3 people that currently play the Raptor. One's a dancer, one's a stunt person, and one is a voice actor. But then I also found an article about Ryan Bond, who's an alum of the University of Winnipeg, who's been the Raptor since graduating in 1995. And he's performed in over 900 games and over 5,000 community events across Canada.
That is a lot.
That is a lot. So maybe he's the Raptor.
Unknown whether he's the dancer, stunt person, or voice actor. I'm kind of guessing not stunt person, because if you started in 95, you might be aging out of the stunt person career.
Well, maybe the Raptor wasn't doing stunts originally.
Yeah, that's a good guess.
All right, moving on. Next, we've got Rodan, a fictional pteranodon. This was a request from ToonRex via our Patreon and Discord. Technically, it was a request for I Know Paleo, but it's looking like our I Know Paleo April episode will be coming out much later in the month, so I didn't want to miss out on the April Fool's festivities. So thank you, ToonRex. Rodan's a fictional monster, or kaiju. that first appeared in the 1956 film Rodan and has also appeared in many Godzilla movies. And it's a giant species of pteranodon. Its name is actually a contraction of pteranodon.
Oh, weird. What do you know? Never noticed that.
Me either until I looked this up. And then it's like, oh, yeah, can't unsee it. Originally, Rodan, or maybe I should say Rodan for pteranodon.
But it's spelled with an AN at the end. So I guess it's a little bit different than just cutting out some letters. You got to shuffle them a little.
I read that they kind of changed the spelling to be less confusing to audiences.
Okay.
But originally, it had a jagged toothed beak and menacing face, but it's changed over time as it's become more heroic. It walks upright on two legs.
You have to.
Well, yeah.
If there's going to be a guy in a suit.
Also, being a pteranodon.
Oh, that's true. That is how they actually walked.
Yeah.
Oh, they might have used their hands on the ground in real life.
True. This one's got brown or burgundy skin and a spiky chest, as well as 2 to 3 horns on the back of its head. And it's a fast flyer. It can create shock waves when flying. And it can also flap its wings to make wind gusts. Its beak is so powerful it can crush boulders.
I feel like this inspired a lot of Pokemon.
Maybe.
As you're saying these things, I'm like, I'm pretty sure I had that move for a Pokemon and that move for a Pokemon.
Yeah, it's possible. Now, in the first movie, nuclear bomb testing nearby where it lives wakes a pair of them up. It's this tragic story. Spoiler alert, the pair of them, both of them end up dead.
It's a tragedy.
Yeah, but that kind of changes in later movies and stories.
They would just bring it back.
I think so. It also became more heroic over time. Sometimes Rodan's portrayed by a person in a suit. It's called suitmation. And sometimes it's portrayed through wire-operated puppets to show it flying.
I like a good puppet.
Yeah. Staying in the Godzilla universe, we've got Godzillasaurus, a fictional theropod dinosaur. This was also a request from ToonRex via our Patreon and Discord, so thanks. Specifically, the request for Godzillasaurus from Godzilla vs. King Ghidorah. So Godzillasaurus is a fictional theropod dinosaur. It first appeared in the 1991 film, Godzilla vs. King Ghidorah. The film, though, is set in 1944. And Japan and the US, they're fighting on Lagos Island, and then they encounter Godzillasaurus. Godzillasaurus starts fighting to defend its territory and gets injured. And time travelers teleport it to the Bering Sea. They think Godzillasaurus is going to die, and they kind of want it to because they're trying to erase Godzilla from history. But decades later, a nuclear submarine crashes nearby, and the radiation turns it into Godzilla. So it goes from Godzillasaurus to Godzilla, which that reminds me of Pokemon too, how you kind of level up.
Yeah.
Anyway, as Godzillasaurus, it's pretty big. It's about 12 meters or 39 feet tall and 20 meters or almost 66 feet long and weighs about 60 tons.
It's nothing compared to Godzilla, though.
No.
But I guess, like you were saying, this is the precursor.
Yeah. And it's very strong. It has a lot of endurance because it takes multiple battleships to bring it down.
They're always bulletproof. That's a requirement.
Good point. It's also capable of swimming and omnivorous. It's got a small head. It walks on 2 legs. It's very bulky with a mouth full of sharp teeth in a double row like a shark. And it's got long arms with claws and a long dragging tail. It also has 4 fingers on each hand and 4 toes on each foot. There's 3 in the front like a theropod, plus a smaller toe with a claw near the back.
A hallux, one might say.
There we go. And it's also got a second brain in its hip, like what was thought with Stegosaurus at one time.
For something that people came up with in the early 1990s, we're a little behind the times with our dinosaur depiction there.
But since the movie was originally set in the 40s, maybe they're hearkening back to what we thought in the 40s.
That's generous, yes.
Originally, the idea was that a Tyrannosaurus would turn into Godzilla, but special effects designer Shinji Nishikawa said that he couldn't accept that idea, so he came up with the Godzillasaurus concept. There is also another Godzillasaurus known as Baby Godzilla, which comes up in the 1993 film Godzilla vs. Mechagodzilla 2. Now, there is a dinosaur in paleontology, back to
real life?
Yeah, nonfiction, named Godzilla lizard. That's Gojirosaurus.
the translated name is Godzilla lizard.
Yes.
The official name's Gojirasaurus.
Yes. Although Gojirasaurus may be a dubious genus, so it might not be a valid dinosaur. We talked about it as the dinosaur of the day in episode 165, but as a quick reminder, it lived in the Triassic and it was much smaller than Godzillasaurus. It was about 5.5 meters or 18 feet long and weighed about 330 to 400 pounds or 150 to 200 kilograms.
It's interesting they picked a Triassic one for that name, though. If it's sort of the origin story of Godzilla.
Oh, yeah.
Similar to the origin story of dinosaurs.
That's a good point. Fun connections, maybe. Interestingly, Godzillasaurus is way bigger than the dinosaurs in Jurassic Park and Jurassic World. I came across this video from MindQ that does a fun comparison. So some of the largest dinosaurs there in Jurassic Park or Jurassic World are about 5.5 meters or 18 feet tall, like Rexy and the Giga. And then there's Apatosaurus that's 6 meters or 20 feet tall, but they look like nothing compared to the Godzillasaurus. There's Spinosaurus, which is about 7 meters or 23 feet tall at the top of the spine. And then it's not until you get to Brachiosaurus, which is 12 meters or 40 feet tall in Jurassic Park and Jurassic World. And that's about the same height as Godzillasaurus.
Yeah, that's pretty good.
Mm-hmm.
That there was a real dinosaur that was that tall. I know in the recent How Dinosaurs Got So Big, you also talked about Sauroposeidon, which could have been about 60 feet tall, would have been even taller than Godzillasaurus.
I'm saying how large the dinosaurs are depicted in Jurassic World and Jurassic Park. In real life, Brachiosaurus, it does fall within that range, but it's estimated to be 9.5 to 13 meters or 31 to 43 feet tall.
Okay, yeah, so about the same. And it wasn't just purely vertical the way that you get with the kaiju. It also had some length to it.
Mm-hmm. And that brings me to our final fictional character, Ultimasaurus, which is a dinosaur hybrid in the Jurassic Park world.
The Jurassic Park universe.
There we go. Better word for
it. So you're not confusing Jurassic Park and Jurassic World.
This was a request from Beanman via our Patreon and Discord, so thanks. And Ultimasaurus was a dinosaur hybrid that was part of a toy line by Kenner called Jurassic Park Chaos Effect. Which reminds me, I think I just heard about a Jurassic Park Chaos Effect show coming to Netflix eventually. Or it could be Jurassic World Chaos Effect. Anyway, these action figures were released in 1998, and the idea was that Hasbro was going to make a TV series to accompany the toy line. So I guess the TV series came much later, or is coming much later. Anyway, they made a bunch of hybrid dinosaurs. Not all of the planned hybrids were made. They got canceled because the toy line didn't do that well. And one of the cancellations includes Ultimasaurus. Some of the problems might have been like the horns were a little too long and sharp. But had it been made, it probably would have had movable jaws and claws. There was an infant Ultimasaurus that came out with one of the human action figures, too. Ultimasaurus is a hybrid of Tyrannosaurus, Triceratops, Velociraptor, Ankylosaurus, and Stegosaurus.
Oh, jeez. What a mess.
It's quite the hybrid. It had a body like Tyrannosaurus, with the frill and horns of Triceratops, the arms and legs of Velociraptor, the back armor of Ankylosaurus, and thagomizers on the tail like Stegosaurus.
I feel like there's a lot of dinosaur toys that are like this. I occasionally see them on different blogs or forums where people are like, what dinosaur is this? And people are like, made up a saurus.
Or a bunch of dinosaurs.
Yeah, or it's got all of these features that somebody just jammed together. Actually, our daughter has that one toy that she says doggy when she sees it because it looks like dog proportions, but then it's got like spikes running down its back and it's got spots and sharp teeth, presumably. So it's also a combination like this.
That's true. Plus, it's a plushie.
Yes. I think for a lot of people, dinosaurs have spikes down their back. That's just like one of the defining characteristics of dinosaurs.
There were a number of dinosaurs that did have spikes on their back.
Yeah.
Ultimasaurus, in terms of colors, it had gray skin with a light yellow underbelly, black stripes on the back, yellow around the eyes, and the eyes themselves were lime green, and then it had a red head and red feet. It's meant to be a deadly dinosaur that's unpredictable. And there's a lot of similarities between Ultimasaurus and Indominus Rex from Jurassic World, especially the being unpredictable part and creating chaos. It kind of looks a little similar too, except for the end of the tail and the Triceratops like top of the head.
Those are some key differences.
Yeah.
The horns
Yeah.
and the thagomizer.
And the frill. One wiki says that it was 52 feet or almost 16 meters long and 19 and a half feet or almost 6 meters tall and weighed 8.9 tons. So it'll be interesting to see if it makes it into this new series. I know almost nothing about the series, so don't have much to say there, but there we go.
There we go. I saw there was also a request for Godzilla because Godzilla's 70th anniversary, I guess, is right now. So that's kind of cool.
Oh, well, that works out.
Because yeah, Godzillasaurus, which is closely related.
Mm-hmm.
The ancestor, canonically.
All right, back to the real dinosaurs. Our dinosaur of the day is Microraptor Revisited. This was a request from Dodo via our Patreon and Discord, so thanks. Microraptor was very bird-like, so it seemed fitting to revisit. It was our dinosaur of the day back in episode 69, but a lot of new research has come out since then, and we've covered a lot of it, but it's nice to have it all in one place. Microraptor was a Dromaeosaurid dinosaur that lived in the Early Cretaceous in what is now Liaoning, China, found in the Jiufotang Formation. It looked like a bulky crow, but with teeth. It is estimated to be about 2 to 3 feet, or 0.6 to 1 meter long, and to weigh up to 4 pounds, or almost 2 kilograms. It was covered in black iridescent feathers, and it had 4 wings, meaning its legs were feathered.
Or 5 if you include the tail.
True, because it had long feathers on the arms, tail, and legs. It had long upper arm bones, and the tail had a diamond-shaped fan on the end. It also had curved claws, and both serrated and unserrated teeth, and relatively short, deep jaws. There was a sclerotic ring in its eye, so maybe it hunted at night, but other features make it seem more like a daytime dinosaur, and a lot or possibly most or all dinosaurs had sclerotic rings, so that might not mean anything.
Yeah. Sometimes people think you can tell by the size of the sclerotic ring. It can help you infer some details about the size of the eyes and the shape of the eyes. So those things can correlate to whether or not they were nocturnal or not. Or diurnal, I should say.
The type species is Microraptor jiaoyanus. It was named in 2000 by Xingshu and others. The first Microraptor specimen found turned out to be a chimera, or composite, of 3 dinosaurs. One of the dinosaurs did include Microraptor.
So they picked one of the 3 dinosaurs to be Microraptor at some point, I guess.
I think so. Well, the tail was what belonged to Microraptor. The rest belonged to the prehistoric Enornis and then an unnamed animal. She was the one who revealed the forgery. A little before Microraptor was named, in the same year, Storrs Olsen published a description of the tail and named it Microraptor. But Olsen said that the fossil was a lectotype, that happens when no holotype's designated, before the type species was formally erected, and the name Microraptor is used more than Archaeoraptor. So Archaeoraptor became a nomum vanum, a name in vain, and Microraptor became a nomum protectum. And that's why we call it Microraptor now.
It's a better name.
It is a little easier for me to say.
Yeah.
Microraptor helped show a bit about how dinosaurs became birds. From the 2000 paper that named it, quote, "This is the first mature non-avian dinosaur to be found that's smaller than Archaeopteryx, and it eliminates the size disparity between the earliest birds and their closest non-avian theropod relatives," end quote. It had more bird-like teeth, fewer tail bones, and that made it more bird-like. The genus name Microraptor means small thief, or small one who seizes.
But I guess with the history of what raptor means in dinosaur paleontology, it's just more like tiny raptor.
Yeah, it's more about the size, being small. The species name jiaoyanus is in honor of Zhao Shijing, quote, "a distinguished dinosaurologist who introduced the first author to the field of vertebrate paleontology."
Dinosaurologist. I don't think I've ever heard that before.
I like that word.
Paleontologist, but specifically about dinosaurs, makes you a dinosaurologist.
Yeah, you know exactly what that person studies.
It's what everybody thinks when they hear paleontologist, but it's good to be specific, I guess.
Yeah, there's a lot more to paleontology than dinosaurs.
Mm-hmm.
Anyway, there's 3 species of Microraptor named: Jiaoyanus, Guai, and Hanqingai. Not everyone agrees that there's 3 species. Some people think they're all one species. But Xu and others named Microraptor guai in 2003 based on having proportional differences from Microraptor jiaoyanus. The species name guai is in honor of, quote, Gu Jue, a distinguished paleontologist who contributed greatly to the study of the Jehol biota, end quote. And then Microraptor hangqingai was named in 2012 by Enpu Gong and others. That species name is, quote, in honor of the late Marshal Zhang Shuiliang, who was the founder, president, and later honorary president of Northeastern University, China. Hangqing is his alternate name, end quote. Microraptor hangqingai is the largest known species of Microraptor, and it's got differences in the sternum and pelvis and having fewer tailbones.
Well, those seem like pretty significant differences.
Yeah.
So you'd think there would be at least 2 species.
I guess it depends who you ask.
Mm-hmm.
There's another dinosaur, Cryptovolans, which has been reclassified as a synonym of Microraptor. That one was named in 2002 by Shirkas and others. The genus name Cryptovolans means hidden flyer. The type species is Cryptovolans pauli, and the species name is in honor of Gregory Paul.
Cryptovolans is a cool name.
Mm-hmm.
But I guess Microraptor beat it by just 2 years.
Yeah. They found 2 relatively complete but partially damaged specimens of Cryptovolans, now Microraptor. It was found to have the same features as Microraptor, like having feathers on the leg, but one specimen had a longer tail than other Microraptor specimens. The tail had 28 to 30 vertebrae compared to other Microraptor specimens that were described at that time, and those only had 24 to 26 tail vertebrae. But as more Microraptor specimens were found, Cryptovolans was thought to be a junior synonym of Microraptor jiaoyanus, and that the differences in the specimens were just due to individual variation.
Seems very strange to me that you would have a variation from 24 to 30 tail vertebrae in one species. Like I guess I could see in one genus, but this seems like a very big difference in the number of vertebrae for a species.
Maybe
this will get split out later and Cryptovolans will make a comeback.
You're just rooting for that name.
I am. I like it.
Well, many Microraptor specimens are preserved in slabs and counter slabs, and there's over 300 specimens known, so we know a lot about this dinosaur.
Yeah.
It was an opportunistic predator that went after fish, lizards, birds, and mammals.
Yeah, for once we know that for sure, right?
Yeah, because there's an example of each one of those. So it's probably had a generalist diet. What's unclear is if it was a hunter or scavenger. But like I said, there's 4 specimens found with gut contents.
There's a good chance, too, that it was a hunter and scavenger. We often say most animals that eat meat will do both.
Yeah, why not both? We talked about the Microraptor that ate the lizard back in episode 245. This one was found with a complete articulated lizard in its stomach.
Mm-hmm.
And this lizard was a juvenile or subadult, and it takes up a lot of space in the Microraptor's abdomen, with its head near the bottom of the stomach and the legs a bit higher and the tail all the way up the dinosaur's sternum. It seems that the Microraptor swallowed this lizard whole and head first, and then it must have died shortly after because the lizard's preserved so well.
Yeah, I think I remember that being used as an argument for it not scavenging and that it might have hunted it because of it eating it head first.
That makes sense. Then there was another Microraptor specimen found with a mammal foot inside its rib cage, which means it ate mammals. We talked about that one in episode 425. This mammal was about 1/10 the size of the Microraptor that ate it. It's unclear what type of mammal it was, but it did have slender toes. There's no evidence of any rupture in the Microraptor's ribs, so it seems that the mammal foot got digested. And because it was digested, it's less clear if Microraptor hunted or scavenged the mammal. It's possible that the mammal was climbing and Microraptor seized it, because Microraptor could probably climb and glide.
Mm-hmm.
But the foot's not the most nutritious part of the animal, so that could have been one of the last parts of the mammal to be eaten, and it was that way because it was scavenged.
Yeah, it's a funny comparison because it's like, was it snapping at it and managed to bite off a foot? That seems a little unusual in a hunt, and that the animal still managed to get away after that.
Yeah. Oh, without a foot? Yeah.
Or was it, just the
dead
last
already.
thing left? Yeah.
Yeah. And then there was the Microraptor specimen found with an antiornithine bird in its abdomen. They found a partial wing and feet. And that bird was estimated to weigh between 60 and 70 grams, and the Microraptor that ate it was estimated to weigh 1,500 grams, or 1.5 kilograms, or about 3.3 pounds. It seems like it swallowed the bird whole and head first, which I guess if we're thinking about the lizard example, could be another case of hunting.
Yeah, could be. It might also just be easier to eat head first.
Yeah.
Like I'm thinking about how when you feed fish to penguins or something, they're already dead, but the penguins tend to eat them head first just because that's the way they've evolved to be the slipperiest, going head first.
Speaking of fish, there was another Microraptor specimen found with fish scales in its abdomen. So, yeah, those are the 4 examples. Microraptor had feet like a modern hawk, which we talked about in episode 432. There was a study that looked at bird feet, and you can tell a lot about an animal's behavior based on their feet. Like, do they spend their time walking or running on the ground? Do they hunt in the air? Modern raptor feet have reticulate scales, which is a net-like pattern, that are sharp to help grip prey. So they basically have spiky scales on their feet to grip prey. And they also, modern raptors, tend to have more curved claws. Microraptor feet had a lot of features in common with modern raptors, even though Microraptor is not a bird. It had spiky scales and strong foot joints, which would help it grasp prey.
I guess it depends on your definition of bird. Some people might consider it a bird. Probably not a crown bird, though, as in the birds that evolved into modern birds.
Right. Well, being a Dromaeosaurid is closely related. The strong foot joints can help with grip force, and we see this in modern birds of prey and Dromaeosauri and Dromaeosaurids. So this would have helped for hunting large, struggling prey. The soft tissue in the feet and claws of Microraptor, too, along with the fact that one specimen was found with bird gut contents, and the fact that it could potentially flap to fly, suggests that Microraptor may have been able to, quote, hunt flying and difficult to hold prey, end quote, which means potentially theropods, small pterosaurs, and gliding mammals that could hunt in the air.
Ooh, that would be a feat.
Yeah. A feat with its feet? Microraptor also had an enlarged second toe, which it may have used to pin prey like Deinonychus did. However, the first toe is the smallest one, and it couldn't work with its second toe to grip prey, so Microraptor may instead have used its body weight to help grip with its large second toe. Now, Microraptor does seem to have a more specialized raptorial lifestyle. Though we still don't know exactly how well Microraptor could fly, it's possible it could at least occasionally snatch something in the air. So yes, there's still a debate over whether Microraptor could fly or just glide. Again, it had those long feathers on the arms and hands and the legs and feet. At first, it was thought to be a glider that lived in trees because the leg wings were attached to its feet, and that would have made running hard.
Meaning the legs were too covered in feathers, so it would slow you down if you were running.
But the limb proportions and then some other features in the skeleton make it seem like Microraptor spent more time on the ground than climbing trees. Some later wind tunnel experiments also found Microraptor was probably an effective glider, and it was possibly capable of powered flight too. It also had primary feathers on the hand and foot and secondary feathers on the arm and legs. The long feathers on the legs were asymmetrical too, like flight feathers in modern birds. And it had a fused sternum, which may have helped with flying. There was a study in 2016 that found Microraptor was capable of using its wings to help it run up hills, as well as using its wings to help it leap. Other studies found Microraptor could fly based on feathers, including how its shoulder curved and the fact that it had a propatagium. Propatagiums, that's the largest skin fold of the wing, and it helps animals with it get lift when gliding or flying.
Yeah, it's the leading edge of the wing, basically, on modern birds.
Yes, so it's important. We talked about how the propatagium evolved in birds and dinosaurs in episode 436, or specifically, Garrett, you talked about it.
Yeah, and how we could tell that they had it because it basically yanked the fossils into this particular position. And you can see that with Microraptor, so we know it probably had that propatagium, even though the propatagium hasn't really been preserved.
Yeah.
Maybe a faint outline on some fossils.
Yeah, like with Microraptor, the elbow angles were at about 36 degrees, so that's pretty bent. Some scientists think that Microraptor may have used its 4 wings to brood or to keep its eggs warm. If that's the case, it possibly sat in the middle of the nest and then covered the eggs with its feathers. And speaking of its feathers, it molted or shed a few feathers at a time. We talked about that in episode 458. There's evidence in one Microraptor specimen where you can see a gap between 2 feathers. It's unclear how often it molted, though. Microraptor probably shed its skin as dandruff, similar to modern birds. We talked about that in episode 373, about the fossilized skin flakes.
Oh, yeah.
In 2018, Maria McNamara and others analyzed this fossilized skin of Bapiausaurus, Sinornithosaurus, Microraptor, and Confuciusornis, and they found that Microraptor shed flakes, or dandruff, like modern mammals and birds, but some structural differences show that it probably had lower body temperatures than modern birds. As for the color of its feathers, a study in 2012 analyzed the fossilized melanosomes in a Microraptor specimen and compared those shapes to those in modern birds. And the shapes were similar to birds that are black and glossy, and similar to a modern starling that's iridescent, so it seems likely that Microraptor was also iridescent.
I always think of crows when I think of the color of Microraptor.
Same. That's why I think of Microraptor as like a crow, but with teeth. I guess the tail's pretty different, too.
And wings on its legs.
True. So some other differences. But it's a good starting point.
Mm-hmm.
Some possible Microraptor tracks have been found in the Jinju Formation of Jinju City in South Korea. We talked about that in episode 209. These tracks are very small. They're less than 1 centimeter or 0.4 inches long.
Those are tiny.
Yeah.
You got to really be paying attention to notice those. Not like a sauropod track that you'll like break your leg stepping in like a pothole.
Unless it's a hatchling sauropod.
It's true.
Anyway, these tracks are named Dromaeosauriformipes rarus. So it's a rare dromaeosaur foot shape. The tracks may have been made by very young juveniles. They're the right size for a juvenile Microraptor. In the episode where we first talked about it, we mentioned how it was so small that with the tail fan, a life-size sticker of the dinosaur would fit nicely on the back of a phone. That's how small this dinosaur was. The tracks were made on a lake shore. There's evidence that Microraptor ate fish, so that kind of goes nicely. But as with all trace fossils, it's really hard to know for sure what particular animal made this track. So we don't know for sure that a Microraptor did. Other dinosaurs that lived around the same time and place as Microraptor include Psittacosaurus, as well as the Tyrannosauroid Sinotyrannus, the Dromaeosaur oolong, the Oviraptorosaur Caudipteryx, lots of enantiornithines and avialans also. And other animals that lived around the same time and place include fish, mammals, pterosaurs, and crustaceans. And now for our fun fact. I guess I ended up doing most of this April Fool's episode.
Mm-hmm.
We're back on Microraptor. Microraptor probably took a while to digest its food and then pooped out bones, fur, and feathers. This was in a study by Jingmei O'Connor and others, published in Current Biology. And they came up with this based on comparisons between Microraptor and Anchiornis. Anchiornis is about the same size as Microraptor. And there's similar numbers of Anchiornis and Microraptor specimens, because there's like over 300 Microraptor specimens and there's over 200 Anchiornis specimens, so we know a lot about both. 4 Anchiornis specimens have been found with pellets, which goes nicely with the 4 Microraptor specimens found with gut contents. 1 Anchiornis was found with bones belonging to a lizard preserved in the esophagus. It was understood to be a gastric pellet prior to digestion or vomiting it out. And then 3 other Anchiornis specimens had pellets with fish bones and scales found near the skeleton, so it seems like it hawked them up just before or after dying. These pellets mean that Anchiornis coughed up the non-digestible parts, like scales and bones. Modern raptors cough up pellets within 24 hours of eating, and it's a more efficient way of digesting food.
Yep, that's what one of my first memories of a science lab was dissecting an owl pellet and trying to reassemble a mouse from the bones that were in the owl pellet.
That sounds difficult.
And it's mostly like mouse hair.
In contrast, crocodilians digest bone and then take several days to 2 weeks to digest, depending on the size of the animal it ate and the temperature that it is while it's digesting.
Because they don't cough up pellets.
Exactly. It's less efficient that way. No Microraptors have been found with pellets, so it seems like it passed the indigestible fur, feathers, and bits of bones in its droppings instead, pooped them out. That means Microraptor probably fully digested instead of egested.
Egested.
Yeah. That's what it means with the pellets. And that means by fully digesting, the food stayed in the stomach longer compared to animals that hawk out pellets. This is all based on coprolites being found in other coelurosaurs, and coelurosaurs include all theropods most closely related to birds than to carnosaurs, and they include Microraptor, Tyrannosaurus, and many more. And some of those coprolites have been found with bits of bone in them.
I mean, they're both valid strategies, either trying to spit out the parts you can't digest or letting it go all the way through. Just whatever your intestines can handle, I suppose.
Do what you gotta do.
Just to get the bonus of maybe getting more calcium and some other nutrients if you digest the bone a little more fully.
Oh, true. And you stay full a little longer. I guess that's good.
If you're a Microraptor on a diet.
I was thinking if it's hard to find food.
Oh, true, yeah.
Well, that wraps up this episode of I Know Dino. Thank you for listening. Stay tuned. Next week, we have an interview with paleontologists and science communicators Tito Aureliano and Aline Gilardi. And they work with a lot of sauropods, among many, many other cool things that they do. If you enjoy listening to I Know Dino every week, then please leave us a review on Apple Podcasts or wherever you listen to our show. Thanks again, and until next time.